Hi, this is Chris, and we are taking a look at our last two multiple choice questions, numbers 29 and 30 here in section 4 of SAT Practice Test 4. So for 29, it says if x is the average or arithmetic mean of m and n, y is the average of 2m and 15, and z is the average of 3m and 18, what is the average of x, y, and z in terms of m? So let's take a look at two ways that we could do this problem. First, algebraically, to find the average, so hopefully by now we know that the average is going to be equal to your sum of terms over your number of terms. So for this first statement here, it says x is the average, so x is, or x equals, the average of m and n, which would be the sum of those two terms, m plus 9. Oh, I said m and n, sorry, I meant m and 9. The sum of those two terms divided by the number of terms. There are two terms there. So that's our expression for x algebraically. Now for y, they say y is the average of 2m and 15. So y is 2m plus 15 divided by 2, since there are still two terms there. And then z is the average of 3m and 18. So z equals 3m plus 18. And that's also divided by 2, since there are two terms there. And now they want to know the average of all three of those together, which would be x plus y plus z all over 3. And if we plug in each of these expressions in terms of m for each, so that would be m plus 9 over 2 plus 2m plus 15 over 2. You can see me writing smaller and smaller because I didn't space it out perfectly. Let's give me a little extra room here. And then plus 3m plus 18 over 2. And the whole thing divided by 3. So on top, if we combine like terms in those numerators, that would be m plus 2m plus 3m, that's a total of 6m. And then 9 plus 15 is 24, plus 18 is 42. So it would be 6m plus 42 all over. Still, the whole thing is over 3. And I think at this stage it's easier to think of this like a fraction. Divided by 3 is really the same thing as saying times 1/3. And so if we multiply this times 1/3, I think it just helps us depict this in a little bit more, I would call it a user-friendly fashion. I'm going to move this over a little bit, but here that would give us 6 on our denominator. So if we multiply by 1/3 instead of dividing by 3 over 1, then that will give us 6m plus 42 over 6. And each term is divisible by 6, so that will give us 6m over 6 is m. 42 over 6 is 7. We get m plus 7 as our answer here, which is answer choice B. So that's the algebraic way to do question 29. And certainly something that we should be comfortable with and a skill set that we should develop, especially if we're tackling tough questions like these come test day. However, let's take a look and see if there's another way to answer this without having to use as much algebra. And that's by using PAM. So this is another great PAM question, pick, answer, match. So here, we're going to pick a value for x, or I'm sorry, for m, and then consequently, we'll solve for the value for x. So if we want to pick something for m, we want to try to make it something that's small and kind of easy to work with. So let's try whatever you think. I'm going to go with m equals 2. You can try a different number on your own. So here, if m is 2, now we can get an actual value for x. And it's okay if you come up with decimals, because remember, this is calculator section, so use that to your advantage here. If x is the average of 2 and 9, so here, when you add those up, that's 11 divided by 2. X would be 5.5. Y is the average of 2m and 15. So that would be 2 times 2, which would be 4. Plus 15 is 19 divided by 2, so it's going to be 9.5. And z is the average of 3m and 18. So that would be 3 times 2. Because again, we're plugging in a 2 for each of these m's. So 3 times 2 is 6. 6 and 18 is 24. So that average there would be 12. And now we're going to answer the question that's actually being asked. And I'll highlight that here. They want to know what is the average of x, y, and z. And the nice part here is we don't really have to worry about what it's in terms of, because when we use this process of PAM, pick, answer, match, we're going to get a numerical result. So here, the average of x, y, and z would be the sum of these terms, 5.5 plus 9.5 plus 12, divided by 3 for the average. So here, 5.5 and 9.5 is going to give us 15 plus 12. That's 27 over 3 is 9. So our answer to the question is 9. And now to match that, we're going to plug in a 2 for m into each of our answer choices, and we're going to see which one comes out to be 9. So here, when we do that math, for A we get 8, not it. For B we get 9. That seems right, but let's check and make sure C and D don't accidentally work out. For C, we get 4 plus 14 is 18, and for D, we get 6 plus 21 is 27. So, nope, it's got to be answer choice B, and that's exactly what we found when we did it algebraically. Both methods absolutely correct. Important to have different approaches in your toolbox come test day. Now let's finish out this section with question 30 over here. So for question 30, we see this graph, and they give us this function. Looks rather complicated, and they say the function f of x is graphed in the xy plane above. If k is a constant such that the equation f of x equals k has 3 real solutions, which of the following could be the value of k? So what's important to note here is that when you have f of x is the equivalent of just saying y, and when you have y equals a constant, or just a number, it's really important for us to know what that's going to look like on a graph, and that's going to be represented by a horizontal line at that particular numerical value for y. So as long as we know what that looks like and we can interpret each of our answer choices here, that's our key takeaway on this question. Because here for each of these answer choices, so we'll start with A. If y equals 2, that means we would have a horizontal line at 2. So that would look like this for answer choice A. And then for B, that would be a horizontal line at 0, which would look like this. For C, you would have a horizontal line at -2, so that would be down here. And for D, you would have a horizontal line at -3, so that would be down there, just below that one. So now let's take a look at what they're talking about. When they say 3 real solutions, a solution, whenever you're looking at multiple lines or multiple functions, they don't have to be straight lines, but multiple functions on the same xy plane, where they intersect is what we're referring to when we talk about a solution. So A would have one solution right here. And remember, they're looking for 3 real solutions, so A can't be it. B would have just one solution right there, so it can't be B. C would have also one solution right there, so it can't be C. And D, if we look at that line represented in D, D has 3 solutions, 1, 2, and 3. I'll circle them as well, but those 3 points of intersection show that the line created